Um, good, good evening. This is my video about my load test process for the toolshop website. So I will go through this test plan that I've created in JMeter. First, I will configure the dataset. Here I use a CSV file, and in this file I have all of the data that I want and I need to use in this transaction right here. And I decided to put all of them in one file to mimic the whole flow from end to end, and also to not open multiple files at a time. So because I have because the file, let me open the file. So here is the file. I use Makaru to generate this file, and we have here, there is the first line is the title for the column, so I check this to true. I want to ignore the first line, and because the number of users exceeds the number of rows of data I have here. I have 1,000 rows of data because Makaru free use only allows maximum 1,000 rows per file. So I have 1,000 rows of data available. So I want to recycle the data when end of file. This is only possible because invoice content can be duplicate. So like the ID of the invoice and the date that the invoice is created will not be repeated, but the content such as the address, the payment method, the items inside that invoice can be repeated multiple times. That's why I decided to use recycle on end of file. And the thread will not stop on end of file. And here I choose sharing mode, share this file for all threads. So I will go through this this thread group. I use a what is this called? Yeah, I installed this plugin called Stepping Thread Group so that I can have I can create this kind of configuration for my performance testing. So for this thread group, it is called stepping because there are such options that allow me to create something like this chart where the ramp where there is a ramp up and ramp down in each step. So basically each step is an interval in time. Here in this test plan, I want to test the website in its normal condition, which is about 1,000 threads, and I have stress tested to find out that 4,000 concurrent users is the limit that this system under test can handle before constantly rejecting and closing connections. So for a normal website, and here we have the context that this site is for tunes only. It is not fashion, not jewelry, or something that people constantly have high demands for. So 1,000 concurrent users can be an acceptable load for normal conditions. So first I will let it wait for 5 seconds before starting the first 50 threads, and then for every 20 seconds I will add 50 threads, which is a not too heavy loads. And then I will hold this load for 1,000 seconds, which is roughly about 20 minutes, just to simulate real life scenarios. And then after this interval, I will stop 50 threads every 20 seconds until no threads access the website. So here I have 6 types of listeners added. First, it's the summary report, displayed in table form. Through this, I can see I can have an overview of how the system under test is performing in general. And here I have the aggregate graph. Actually, we will also have the aggregate report here and a graph here too. So it's like 2 in 1. I also have a simple data writer just in case I will need it in the future for other types of reports. Here I have results in table and in tree to debug. The tree form will let me see the details of errors happening in each request, while the table will give me information about the sample number, the start time, the thread name, the label. So I have more information, just not the details into why that particular thread fails. I will also have here a listener called response time graph. This graph will just draws data from response time, and it will show something, and we will see that in just a few minutes. Here I use a transaction controller, and I will generate parent sample, which means that that the payment will become the parent of all these samples. We will also get information about these samples in samplers in the summary report, but also under the parent payment. Because the reason why I use transaction controller instead of separating all these samplers is because I want to simulate a real life scenario where the user visits the website, they log in, and then they choose something, add to cart, and then they pay. And after they pay, logically an invoice will be created and added to their list of invoices, and then they will log out. That is the whole payment, and I want to ensure that the whole process is smooth. If I only test the payment alone, it will not be sufficient enough, because in real life, when you interact with the UI of the system, the user must log in before they can proceed to check out and pay that order. So here the first sampler is a post login. Here we have the email. This is the body data of the request. These are variables that will be read from the data file. And we have a header manager here. This JSON extractor is to extract these variables from the response of the system, and we need these to authorize the user in the next samplers in the transaction. And for most of the samplers, I add this response assertion, to ensure that it actually succeeds. So the code for success is 200 or 201, depending on the request that I am sending to the system. And here I have this sampler just to get the user ID. The reason why I have to have this step in the transaction is because in the invoice creation, I need this variable here, and this user ID is generated automatically by the system, not something that I can register through the API. So I must have this step to ensure that this works. And here for user ID, we can see that there's another header here called authorization with a token type and access token, which are all extracted from this response here. And this is to extract the ID from the response. And here we come to the main part of the test plan, which is the payment. Here we will send a post request with these data. In the header, this payment in the API, it can happen without authorization, which conflicts a little bit with the business logic. But because I'm assuming that the API is functioning properly, I'm just testing the performance. So here I'm conforming to the schema described in the API documentation, and I don't add the authorization and the token here. I also assert the response. Same for invoice. Here the total and invoice items, I set these I set as absolute value, because it does not play an important role in this test plan. Here we have a header manager, get logout. The invoice creation is actually added just to conform to the business logic of a normal payment, because you expect to receive an invoice after you pay, don't you? So that's why I have the invoice creation here, just to mimic the normal flow in the real world. And here we log out, because it doesn't make sense if you continue to log in if you don't log out. And I also assert it and have this here. this lockout part will invalidate this token. And here I set a default for the HTTP request. Okay, so we have gone through the test scripts, the test plan, the execution step. The payment transaction will follow this exact order because it's a transaction. And so now, after going through the configuration, we will run this test plan to see what's going on. Here we'll overwrite all of these files. And here we go. We are having 50 users. And currently the throughput is about 35. So this is the end of this load test scenario, and in this test case, my expected output is, let me just reload. This is the summary report. So here we can see the report. In this report, we can see the payment, which is the parent sample, including in this payment transaction is 5 samplers. And here we have the data for all of these. So I want to focus on the error rate. Here, for 1,000 concurrent users held for 1,000 seconds, we can see that the error rate is 0, which is a good sign, and it matches the expected output. Also, the average response time of the whole transaction is under 30 seconds, which this result totally satisfies. And it is just like 2/3 of the expected output. Considering there are 5 steps in the whole transaction, this figure is a positive sign for the system, especially for the payment and the invoice creation. The two main steps in this test plan, the average response time is under 4 seconds, which is fast enough. And looking at the maximum response time of the transaction, in this test case, my expected output is that it will be under 1 minute, considering the maximum happening during the 1,000 users concurrently accessing the system. And here it is beautifully under 1 minute, and it's just like half of 1 minute, which exceeds the expectation. And for payment and invoice creation, the maximum response time is not too bad, about 8 for both. And the throughput of this test plan is incredibly high. About 82.3 transactions per second. And for payment and invoice creation, these numbers also matches the expectation, which is from 40 to 45 requests per second. So all of these numbers all of these numbers show that the system conforms to the expectation under normal load. Now let's see what in this response time graph, we can see that at this time stamp, which is about 5 minutes, from the start. Here we can see that at 5 minutes we reach the maximum number of virtual users, and this is the time when the response time started to increase, and it kind of remained in a plateau. It fluctuated, but did not exceed 30 seconds. Here we have a local we have a peak. This is the maximum, the global maximum of this graph, and it does not exceed 1 minute. And then when we ramp down, we can see that the response time gradually decreases as expected. So, and especially after this peak, the system kind of recovers from that and output a fairly normal response time considering this plateau. So overall, this test case is a pass. This is another form of the summary report. We can see that here 95% of the transaction under 29 seconds, and that also matches our expectation, because most of our requests are processed fast enough. So now we will stop this recording, and this is the end of my load test. Thank you very much for watching this video, and in the next video we will continue with the last test, which is the spike test, also for this payment scenario. Thank you very much.